Now this is part 2 of the Trig final review, Trig 1. Okay, starting off with this one. So in my calculator, so a couple things that you guys can do on this one. So the number one thing I want to look at would be to take my values and plug in each value in the calculator and see, does it meet the criteria? Greater than, less than, all that good stuff, right? So don't forget, alligator eats the bigger number. You guys remember that?
Yes.
Okay, I hope so. All right, so I'm going to take a look at mine. When you pick up your calculator, what's the first thing you should try and do? Clear up your scratch pad, right? So everyone's going to clear up the scratch pad. So we're clearing up the scratch pad. So we press Document B. There we go. And I'm starting this. My calculator has to be in degrees. So please double check. On my last class, we were going over this, and they started changing it to Radian for their problem. So make sure you're in degrees. So watch this. Sine. If you guys remember this from back in the day, it's 44. Close. And we could actually put that symbol in there, which would be control equals. There, put the alligator in there, right? And then put sine 26. Close. And I hit enter. And my answer is going to be false. Look, it actually tells it for you. True and false. So now my first one's going to be false. Now let's do the second one. Secant 65. Ah, dang it. Control divide. There we go. And right here, and it's going to be secant 45. False. Next one's going to be tangent of 26. Tangent 41. True. Ah, that's a true. Sorry. There. Wow. You know, I probably shouldn't be standing like this, but still. My cardboard box is getting in my way. All right, so cosine of 24. Of cosine of 29. False. So, which of the following is true? My answer is C. There we go. It's not that hard to do, right? So it's pretty easy. Calculator does it. Now, the only one that you're going to have issues with are ones that are undefined. So like tangent, if we do tangent of 90, tangent's going to be undefined, but the cotangent will not be undefined. Okay? But the calculator just takes the reciprocal of the tangent value. So it can't do 1 over undefined. It gives you an error right there. That's the only time that you're going to have problems with these ones. Okay, so now find decimal approximation for this next one. So let's go ahead, make sure your calculator's in degrees. Again, so it's going to be tan of 733 degrees, 25 minutes. Enter. 20.2385. There we go. My answer is C. All right, so 21. Now, what does this mean right here? Where is that located at? First quadrant. First quadrant. That's important. It's first quadrant. So now, if I was going to try and find this, I'm trying to find the angle, right? To find the angle, I have to do the no and no. Something I have to do. I heard it.
Inverse.
Inverse, right? I have to do the inverse. So when I'm actually trying to get this and actually break it up, it's going to be inverse. So I'm going to write this out. So it's going to be cosine inverse of 0.44307 is equal to my theta. So we have to put it in the calculator as such. 0.44307. 63.7 degrees. There we go. Now, last class we found all kinds of problems with this one, and I'm going to tell you it's not going to be the same problems like this. They found typos on this one. Okay, now one of the typos is, let's watch closely. If this is big A, what's that?
Little a.
Little a. What's this side over here going to be?
Little b. Little b.
Little b, very good. It's across from the big B, right?
Yeah.
So now, one of the typos is, so that means this side right here would be little c, wouldn't it?
Yeah.
So that means all these ones right here are wrong.
Oh, wow.
Okay, I don't know if anyone else caught that, but they were pointing that out last hour. So we're going to do this, but we're going to solve for A. Because you're going to have to do this a couple different ways. So let's solve for A. So if this is my reference angle right here, this side is the opposite, and this is? Okay, so that's going to be? So tan of 35.5 is equal to A over 15. Multiply both sides by 15, right?
Yeah.
So it's going to be 15 tan of 35.5 equals A. A is going to be a boot, 10.7. So put that in the calculator and we get about 10.7. So here my answer has to be A because that's the only one that actually fits that, right? Okay. Questions? All right. So let's take a look at 23. Now on 23 here, what's going to be the one thing that's going to help me the most for this?
25.4 degrees.
I heard it.
Elevation.
Elevation, but putting all that stuff together, I got to draw it, right? Yeah, that's going to help me out the most. So I know it's going to be a right triangle. Right here, the angle of elevation. So angle of elevation goes
25.4.
and goes up, right? And depression goes
Down.
okay, so that's going to be right here, 25.4. And the building, 223. And we're trying to find this value right here. Opposite adjacent is what ratio?
Yeah.
So I'm going to have tan of 25.4 is equal to 223 over x. Now, you guys should be able to do this by now. Multiply both sides by tangent, or I'm sorry, by x, and then divide by tangent, right? So it's going to be x equals 223 over tan of 25.4.
470.
Okay, so I'm going to show you guys here. So control divide. So was it 223 over tan of 20.4? Okay, 469.6. So my answer is 470, which is B. All right. Questions?
No.
Good. All right. 24. Now, that's important right here. When we say coterminal, we're meaning what? What we did coterminal yesterday, what was it? Anyone, coterminal yesterday meant what?
360.
Adding 360, right? Adding or subtracting 360. But if I'm doing radian, it's not 360, it is...
90.
What's a whole circle in radian?
180.
2 pi. So in radian, it's going to be 2 pi. So if wherever I start, so if I were to draw a circle like this, and I would say, here's my quadrants. This is going to be pi over 8, which is right here. So if I want to come back to this spot right here, I would have to add 2 pi, right?
Yes.
To get all the way back over there. So adding 2 pi again, and keep adding 2 pi to getting back to the same spot, right? So it'd be whatever this is plus, so what is my answer?
A.
Oh.
Why is it not A?
Because it doesn't have a...
It doesn't have a pi, right? And why is it N? means how many times are going around, right? So if it goes around the block 3 times, it would be 3 times 2 pi, right?
Yeah.
Okay, that's what it means. Okay, so let's take a look at 25. Convert this degree to radian. So I have to multiply by what? Pi over 180. So 720 times pi over 180. So if I put that in my calculator, do I include the pi?
No.
No. So it's 720 times 1 over 180, right?
Yeah.
Okay. Right here I got my fraction, which is just 4. And if it's in terms of pi, it'd be 4 pi, right?
Yeah.
So my answer is going to be 4 pi over 1. There we go. All right, so now for this next one right here, for this, convert this to radian. So now what converting to radian would multiply by?
180 over pi.
180 over pi. So negative 5 pi over 4 times 180 over pi. What's going to happen to my pi's?
Yeah, cancel out.
Cancel, so I could just put it in as is, right?
Yeah.
So it's going to be negative 5 over 4 times 180, right? Which gives me negative 225. So my answer is what? None of the above. All right, so convert this one to radian, this radian to degrees. Again, so it's going to be 5 pi over 8 times 180 over pi. So again, pi's will cancel. So 5 over 8 times 180, right? So that's going to give me, it gives me a fraction. How do I get rid of the fraction? Okay, I could do that. What else would be simpler? Control, enter, and it gives me the decimal for that one. So my answer is going to be 112.5, which is A. All right, let's take a look at, 28. Trying to skip the page too soon. All right, so now to give this one an exact answer, I have to use what? Unit circle. So now I'm going to use the unit circle that's given to me on the review, which is in the front cover, and I can't seem to find mine. Yes. Yeah, go ahead. All right, so on mine, I kind of marked it up already. So it's asking for, what's it ask for? Negative 9 pi over 4. So now let's take a look. So if it's negative, I need to go which way? Backwards. So if I'm counting backwards, negative 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, 7 over 4, 8 over 4. What is 8 divided by 4?
2.
That's 2 pi, right?
Yes.
Okay, so that's 2 pi. So that's going to help me out. That's 2 pi. And then now I just go one more, right?
9 over 4.
So this would be negative 9 over 4 to here, right? So it's asking for the sign value. The sign value is the y value, right? So it's going to be negative radical 2 over 2. Right? And so my answer is right there. So the answer is D. Now, for 29, it's asking for exact answer also, but for cosecant. Cosecant is the, say reciprocal.
Reciprocal.
That's a reciprocal, so I'm going to flip it upside down. So I'm going to go with my 7 pi over 4, and it's the reciprocal of sine, isn't it?
Yeah.
So I'm going to have right here. So if you guys get lost, it's also right here. Look.
So it's negative.
Okay.
So it's 8.
So it's going to look like this. So it's going to take this one right here. So negative 2 over radical 2, right? Because I took it and flipped it over. I took the reciprocal of my answer. And now, is that answer done?
No.
What do I have to do? Rationalize. Multiply top and bottom by rad 2 over 2. Like that. Rad 2 over rad 2.
That's negative.
So negative 2 radical 2 over 2.
The 2 crosses out, so it's negative radical 2.
Negative radical 2. The answer is A. Now, on number 30. On number 30 here. Okay, my formula, S equals R theta. Now, the biggest problem that I noticed that when people were working on this one, you have to convert to radian. It has to be in radian for this to work. Has to be in radian for this to work. So, for this one right here, I have to convert this one to radian. So it's going to be S equals, what's my R? 15. And it's going to be times 110 pi over 180, right? So it's basically, I'm just multiplying by pi over 180 anyway, right? So I'm just going to do it all in one step. The reason why I'm actually multiplying the pi in here, are these in terms of pi?
No.
They're not in terms of pi. So that means that you have to multiply the pi into it. Okay, so it's going to be 15 times 110 pi over 180. So I get 28.8. So it's about 28.8. So it's going to be C. Questions? Okay. Important thing about this, make sure you have radiant here. Now, this one here, if I doubled the arc length and the central angle remained the same, I'm going to tell you right now, this one was on our last test that we had like this. I think it's our Unit 2 exam. It was the same question too. What do you think happened to it? If I double the arc length, what happened to the radius?
It doubles.
It doubles. And so therefore that this 15 turns into a
30.
30.
right? Okay. All right, so let's take a look right here. So find the area of the sector of the circle intercepted by this central angle, radius of this. Now, I have the formulas in the formula sheet. So area is equal to, what's the formula, you guys? You're gonna have to get used to checking that.
One half
1/2
R squared.
R squared,
Theta.
and theta has to be in radians, has to be in radians. So area equals 1/2, so R squared, so it's gonna be 8.8 squared times 235 pi over 180, because I'm converting it to radians, right? So let's go ahead and throw that in the calculator. All right, I get my answer as 158.8.
Oh.
Are we okay? Letter A. Question? All right, let's take a look at 33. Now, where is this located at? Where does it say I'm looking for this? Unit circle, but where in the unit circle? Between 0 and pi over 2 is what quadrant?
Oh.
First quadrant. That's important, first quadrant. Now, for tangent, we know tangent is what over what? Y over x. So now, where is the y over x the same? Because y, to get 1, it would be the same y and the same x, right? It would be pi over 4, wouldn't it? It would be pi over 4. So pi over 4. So now, for this one right here, what is it asking for? You need to have the decimal, right? Okay, so you can calculate the decimal. So that is using the unit circle. What else could I have done instead of using the unit circle? Am I looking for this angle? Say yes.
Yes.
If I'm looking for the angle, I could do the,
Inverse.
thank you, inverse tan of 1 is equal to my W, right? So let's see. So inverse tan of 1. Okay. Now, what's wrong with that?
It's in degrees.
It's in degrees, right? So this is one that you have to make sure that your calculator is in degrees. So let's go and change that. Document, settings. I'm going to change this one to radian. And then make default. There we go. Now let's try it again. So there's my answer in radian. 0.78539, blah, blah, blah. So my answer is
A.
A. Any questions? No questions? We good? All right, number 34. Linear velocity. So linear velocity, let's take a look. So linear velocity is on my thing right here. So the reason why I'm showing this one and I didn't show my other ones. So linear velocity is here and there's 3 different ones, right? Okay, so we use the one depending on the information given to me. So let's take a look of a point on the edge of wheel rotating 40 times per minute. Okay, 40 times per minute. So let's take a look. So if it's 40 times per minute, if it's rotating 40 times per minute, what does that give me? Times per minute.
Right.
Okay, so now think about it. Where R is the radius, theta is the central angle. Okay, now W would be angular speed, isn't it? It's radians divided by time. Okay, so now if I think about this, 40 times per minute, that's going to be 40 times what?
60.
So if it rotates all the way around, how much is that? If it rotates all the way around, what do I call that? 1 revolution. Each revolution is how much? 2 pi, right? So each one of these is going to be 2 pi. Each one of those. So it's going to be 40 times 2 pi is my W here, right? Because it's already in times per minute. So it's going to be 80 pi is my W. And that's important. So I have the W, and I have that the radius is 10. R equals 10. So let's take a look. So right here, for linear velocity, I go with what's given to me. So I have a radius and I have a W. So I have to use this formula right here. So V equals RW. So V equals R, which is 10, times W, which is 80 pi. And plug that in. All right, so now for this one right here, because it says per minute in the time given to me here, and I'm trying to find my answers in seconds, right? So I'm gonna take this one right here. So it's gonna be, let's see, 2513, and this is gonna be centimeters over 1 minute. So I would have to multiply this by, I can grab my scratch paper so I don't write all over everything else. All right, so it's going to be 2513 cm or 1 minute, times, now, for my unit conversion, where's minute have to go? On top. So it's minute on top. What goes on bottom?
Seconds.
So we know that 1 minute is
60 seconds.
60 seconds. So what am I going to do with my value that I have right here? Divide by 60, because the minutes will cancel. So I take my answer that I have right there and I divide that by 60. And I get 41.88. So that's going to give me answer C. All right, so we'll pick up the rest of it a little bit later.